pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Good afternoon, and welcome to the Board of Public Affairs meeting for February 16th, 2016. First on the agenda is to approve the minutes of the February 1st, 2016 special joint meeting and the February 2nd, 2016 regular meeting. If there aren't any additions or corrections, I'll ask for approval, please.
I see no additions or corrections. I vote that we approve the February 2nd meeting.
Second.
Dick?
Yes.
Karen?
Yes.
Jim?
Yes.
Bill?
Yes.
Tom?
Yes.
Next is a hearing of public concerns. Anybody present that'd like to address the board that isn't on the agenda? Seeing none. Move on to Clerk-Treasurer's report.
The board's been presented with the Clerk-Treasurer's report for the month ending January 31st, 2016.
Can I have a motion to approve?
I move we accept.
Second.
Bill?
Yes.
Karen?
Yes.
Jim?
Yes.
Dick?
Yes.
Tom?
Yes.
Next is a resolution adopting the Bryan Municipal Utilities Compensation Plan.
Okay, this will be resolution number 4, 2016, a resolution adopting the Bryan Municipal Utilities Compensation Plan for Bryan Municipal Utilities and repealing any portion of prior resolutions inconsistent therewith. So, about a year ago, we hired a human resource firm to look at our compensation plan for those hourly employees that were outside of the union contract. Okay, and we really wanted a non-partial opinion from a professional firm to come in and help us with this project. So our goals at the time for the plan, we wanted a logical and valid method of grading the worth of each classification to the organization. So we wanted to benchmark those. We wanted to consider our current wages and our labor market for comparable jobs today. We wanted it to comply with the governing laws, regulations, resolutions, and be defendable in court if we ever had to go that far. We wanted it to be committed to writing and communicated across all levels of the organization. So this plan would be across the board. And the plan must balance the employees' demands for the wages as well as the public's demands for controls of expenses. So there's a lot going on there. That's why we needed some assistance on this. So we worked with Clemens and Nelson for over a year to work on this project, and part of that project was going over all of our jobs as they are here, non-union positions. Also looking at the classifications and the actual duties of those classifications. We also wanted to develop a compensation philosophy that recognized contributions made by the employees to provide the service they do, but we wanted that compensation package to be fair and equitable, that recognized individual performance levels within, again, as I said, practical budgetary constraints. Okay, so part of this process we used a point factor analysis, and those are a matrix that measures the differences between positions in terms of the relationship of the requirements and the position itself across the board of all our jobs. So in other words, I'm going to go through this lengthy process real quick here. Inside of that, there's 12 criteria that was measured. So we looked at the positional education, so the position, the educational level we needed for those positions, the experience that we want to see in those positions, be it from the lower level, entry level to the next level to the senior level. We want to look at the position's complexity of duties, and what kind of duties were we requesting for this position, and realize, well, I'm calling out positions. This is not a people thing, it's a position thing, and what we want to see in these positions, okay? Supervision received was another area that we evaluated. Consequences of errors, we evaluated that. Supervision received, consequence of errors, contact with others, how much interaction and at what level does these positions interact with the public, other departments. I mean, so it's a bigger picture there. The confidentiality of the information that is garnered in each individual position, mental and visual demands and skills that are required for those positions, physical demands, the work environment itself, You know, we know there's a major difference between a office staff member and a field staff member for their work environment. Character of supervision, that's how supervisory responsibility is how much supervisory responsibility is involved. How much do you receive or how much do you have to give? And then the scope of supervision, which is very simply, how many people do you supervise if you're a supervisor, okay? So on top of this, so we had this matrix that assigns a point value to all these things. On top of that, we had Clemens and Nelson provide us with a comprehensive wage survey. And this wage survey encompassed pretty much a 50 to 70 mile radius around Bryan. Okay, so we realized the economy of scale is we can't compare ourselves with a day in Ohio because there's no way that those numbers work. But within this region, that's the pool we want to tap into for good, for employees at certain levels, so we wanted to look at that. On top of that, we also wanted the study to look at the revenue streams of our utility and compare us with revenue streams of others, as well as the customer base, how many customers we serve versus others our size, and the offerings of service. So again, what do we offer? Power, water, generation, all these assets, and what are the other ones out there like us offer, and how do we compare to that? So all this whole process developed in a point factor range and a wage scale range that were sort of meshed together. And inside of that meshing is the building of this compensation plan. So the document that we are presenting to you folks is a rather labor-intensive document to put together, and it's very comprehensive. It goes through the philosophy, how we got from point A to point B. It gives you the things, the criteria that we benchmark against, and those benchmarking criteria will be standardized then from this point on. It also breaks out the compensation plan as it stands from what the industry sees as a beginning, a middle, and a top end. Okay, so with that, we have presented that plan to you folks in your packet. We also talked about this a little bit prior to. Again, this will be a tool for us as well as the board. So a tool in the sense of we will be able to, if we feel that a person or positions merit the next move up, we will have a tool in place where we can evaluate against and bring to the board that you guys can look at and say, does this person meet this position's criteria to be here? Okay? So the wages that we would pay are also built into that, and that would be another question as a board member you'd ask, does this fit the package that's in front of us? The plan itself has a evaluation period, which means every 3 years it's built into the plan that we would have to look at the plan and re-benchmark and make sure that we are still being competitive or that the industry is still commanding the rate of pay that it is. As well as also it takes in the fact of inflationary and all these other things, okay? Because you really, a good compensation plan is something that just doesn't get put on a shelf and we go, yes, look at us, pat ourselves on the back, we have this plan. It is something that has to be taken care of, monitored, measured against, and go from there. So, long story short, I know I threw a bunch of information out there. What has been presented to you is an actual compensation plan strictly for Bryan Municipal Utilities. This is not a city compensation plan, okay? And I don't want to sell this as the city's of Bryan's. It is Bryan Municipal Utilities plan that we put in place for our utility, okay? So with that, I will answer any questions you may have. Go from there, I guess.
So this is a non-union
Again,
compensation plan?
yep,
So
non-union compensation plan.
for the audience, just addressing the union compensation plan as part of the contract?
Yes, so all our union employees their wages are negotiated under the collective bargaining agreement.
And their
And
job
that-
classifications are
all the same way. And truly, the benchmarking that's used for those is very similar to this. I mean, there's a way to benchmark those positions as well. So before we go into any negotiations, which is usually a 3-year rotation on those negotiations, we have benchmarked our positions that we have against, again, a utility our size, revenue streams our size, the things we offer. We benchmark all that so that when we know when we go in, we are offering a fair package, as well as we have an opportunity then to go out and get those employees at a certain level of skill sets that we need. In the past, we really struggled with trying to hire certain skill sets here because the package itself didn't make sense. What, not just because the insurance benefit was great here at the city of Bryan, it was other things involved. And now we finally got a package for the union as well as what I believe for the hourly employees that are not part of the contractual bargaining unit to mirror each other.
Was there a point system on the union side, just like there's a point system on this side?
The benchmarking on the union side, we typically will start to research contracts that are very similar under CERT, that's recorded at the state of Ohio, with utilities like ourselves, and we start to build that benchmark ourselves. I did not hire a firm to benchmark our outside skilled tradesmen.
If we realize in the future that we're falling behind, or, falling behind what the rest of the industry is paying, this gives us a way to adjust.
The ability is open in here for the board to address that on a, like I said, on a 3-year rotation where you're re-benchmarking and evaluating those needs. You did hit a nail on the head. Our industry today, be it everything we do here, is no longer as simple as you teach a person how to change a hydrant out, or you teach a line worker to do X, Y, Z. There's a lot more education behind it, a lot more skills behind it. To be competitive in the market, we still have to encourage training, schooling, and we have to pay for that service. I mean, the bar has been set pretty high.
Any other questions?
I know we spent an awful lot of time digesting
Yes, we did.
in the beginning. I, for one, was very confused, but once I figured it out,
Yeah, it makes sense.
it's a great thing. Plus, it encourages us, I think, to keep the good employees that we do have, the people that have the skills, the knowledge, the education.
Any other questions? Can I have a motion?
So moved.
I'll second.
Dick,
Yes.
Tom,
Yes.
Jim,
Yes.
Karen,
Yes.
Bill.
Yes.
Okay, next on the agenda, a resolution authorizing an annual wage increase for BMU employees.
Okay, this would be resolution number 5, 2016, a resolution authorizing an annual wage increase for Bryan Municipal Utilities hourly and salaried employees. This resolution sets an hourly compensation percentage rate for those that are not part of the collective bargaining unit. So these are all the hourly and salaried employees here, based on earlier in the year recommendations from the board in discussion. This would be set at 3%.
That pretty much mirrors what
It does.
the union contract.
It does. Yeah, and typically we would have had this in place and probably passed by the first half of the year, but because we were working on the compensation plan, we wanted to make sure this fit in with the plan as a group, as a unit, as it came through. So that is why we held off until now.
Any questions from the board?
What was the percent the last time that there was a raise?
So, I'm sorry?
What was the percent the last time that there was a raise?
Last year board approved 3%. Union contract is 3%. This year, the final year of the union contract is 3%, and the board has been presented with the same.
Now, will there be employees that have reached their maximum, which would equate to a stipend?
With the approval of the compensation plan, if there are those employees that have met their maximum, they will receive a stipend check for that 3% or whatever that difference is. And that's a good point. We understand, and we want the community to understand that the top end, if we have an employee that is a very seasoned employee, which means you have a lot of years of service here with us, and you have been at the top of that pay scale, we don't keep bumping the top up. The top is where it sits, and a stipend check is cut. So you are correct.
Any more questions? Can I have a motion to approve, please?
So moved.
Thank you. Second.
Second.
Dick,
Yes.
Tom,
Yes.
Jim,
Yes.
Karen,
Yes.
Bill.
Yeah. Boy, then you panicked there for a minute. I'm thinking, okay, what do I do now?
Okay, next is a resolution authorizing the purchase of a Case Backhoe for the water department.
Okay, this will be resolution number 6, 2016. A resolution authorizing the Bryan Director of Utilities to purchase a Case 580 SN four-wheel drive or F4WD backhoe for the water department through the state purchasing program from Myra Equipment, Ridgeville Corners, Ohio, for a total of $98,630. So our current backhoe was purchased in 2001. It is 15 years old. It's in the replacement range. This backhoe that we have right now is predominantly used. It's a predominantly used piece of equipment today. I mean, it is out there in the field every day. With that in mind, the unit has developed a couple leaks around the head gasket, and rear differential seals are having some leaking issues. We knew we were going to replace it. That was in the budget for $110,000, so it was budgeted as a capital item for this calendar year. Now, I do want to point out, and this is where it will get a little muddy, repairing our current unit today is sort of cost prohibitive, because by the time we repair it and rent a backhoe during that time frame, because we still have to have a piece of equipment here to do the work, we'd be well above 50% of the cost of this unit right now, this new unit, okay? So we looked at trading, using it as a trade-in for one thing, but I was rather taken back on the trade-in value, what was offered to us. It was around the $10,000 range, and we know that particular backhoe with what is on it and how it's been taken care of should go for anywhere between $18,000 to $24,000. So we sat down as a staff, talked with Matt Killian. I'd forgotten that our power plant in Auglays has the 1988 backhoe from the water department that they use for things down there. So at that time, made some phone calls, talked to our maintenance guy, Mr. Kevin Bulmer, and I asked Kevin about what's his feelings. I said, do you agree, or you can disagree with me? Do you think that's a good move down there? Because they won't be as hard on it, because it won't be out every day, but it meets everything we need down there, and a little bit of TLC can make this thing go for quite a bit longer, another 5 or 10 years at that usage level. And he agreed. I also put a phone call out to Lori and said, hey, on that, if we can do this, is there an issue transferring that capital? I sat down there and she said it's not. She'll take care of that for us. So I try to hit every angle on this. So the other side of this is the state terms contract. That particular contract, Case has provided almost, is it 43% or 46%, John?
45%.
45% discount on retail cost of that hoe. This backhoe would normally be well over $175,000. I mean, this is a very good price. The bells and whistles that are on it are exactly what we have on ours today, with 1 or 2 extra little options to make our job easier, but it did not increase the price by that much at all. So I would request, if we could, to approve this purchase, because it's about a 12-week out item. We have to order it and have to go through that process.
Brian, what cost are we going to incur to the unit we have now to send down to Auglays to use?
Hopefully none. After talking with Mr. Ballmer and Auglay staff, Matt Killian's here, they use the unit to predominantly pull out the barges and whatnot from the river that they use to put buoys and whatnot up, and they also use on the other side to clean up a lot of the riprap and just miscellaneous things. It's not out working every day. When I talked to Kevin Ballmer, he said, if you keep an eye on the head gasket leak, he said they put some material in there to help seal it up. And he goes, and it's lasted a while. And he goes, and if you're not beating on it, he said, you guys should be fine. So I'm anticipating these guys are really good down at the dam on their maintenance and monitoring these things. After all, they have a 1988 down there that's still functioning. It's on its last legs. It's limping along. And I remember in 1988 when that was purchased, because I was a summer helper here. So I remember when that came in. And I do know that our staff is, when we're digging and doing water lines, they're hard on equipment. I mean, they put it to work. So
That one down at the dam might be functioning, but trust me, it's scary, isn't it?
Huh.
Oh, yeah.
Now, and I will be coming to the board at a later date for the one at the dam to ask permission to take sealed bids on to move that out of our system. So realize that one is going to find a new home. We just have to get it back here, go through it, and get you guys' permission to do it.
And we're following suit, and what we've done for many, many years is to take a piece of equipment, move it to another department that can get some use out of it before it is fully expired. So it's a good move, and you are saving a lot of money on this backhoe. It's amazing.
Yeah.
Yeah, we were pretty excited that they gave the 2016 year at the same rate as the 2015 year.
And I did my math, we saved a ton of money by going through the state. I was actually shocked that it was that much.
Any more questions from the board? If not, can I have a motion, please?
I move that we authorize purchase of the Case Backhoe for the water department.
Second.
Tom?
Yes.
Karen?
Yes.
Jim?
Yes.
Dick?
Yes.
Bill?
Yes.
Next on the agenda, a request to put John Degroff on regular employment status.
Okay, this would be a request to move John Degroff from probationary employment status to regular employment status. As a probation, well, John's a probationary laborer 3 right now, and I'd like to put him in regular employment status as a laborer 3. John is dependable, hardworking, and he is very much a team player. He completes his daily task in an efficient manner with little supervision. John is one of the key, I'm gonna call players or people that makes this place look so nice in the summertime. If you drive by out front here, our place is manicured. I mean, we would pay a lot of money to have this done. John takes great pride in that. So as a laborer, he always pitches in and is always busy. He's an amazing man when it comes to that. So I would recommend, if we could, to move John Degroff to regular employment status as a laborer 3.
Questions? Motion?
So moved.
Second.
Dick?
Yes.
Tom?
Yes.
Jim?
Yes.
Karen?
Yes.
Bill?
Yes.
Next, a request to put AJ Geren on regular employment status.
Okay, we would respectfully request to move AJ Geren from probationary power plant operator 3 to regular employment status as a power plant operator 3. AJ continues to improve upon his skills and knowledge in all phases of power production. He's completed all the necessary schooling. Most recently, he was actively involved in the repair of the lower bearing on Unit 2 down at the Auglaize. He's been part of the group that's had helped Sulzer in the repair of the GT2 rotor repair. AJ's brought a lot of knowledge from the field and the metering side into the power plant side and really strengthened the group, as well as they've helped him step up to the plate. So, you know what? He's ready for this. So again, I would request that we move AJ from probationary to regular employment status as a power plant operator 3. And I'll answer any questions if you have them.
He's had some training too, hasn't he, over the recent years?
AJ did the metering training when he was part of the distribution side, and now he's part of the substation and generation training. So we have some members over there taking 2 different types of training. AJ finished year 2 and is beginning year 3, so he fits exactly where he should be schooling criteria-wise and skill sets.
Good.
So,
Any more questions?
There's no pay increase, it's just a status.
nope, just coming off
change.
probation. Yep.
So moved.
Second.
Bill?
Yes.
Karen?
Yes.
Jim?
Yes.
Dick?
Yes.
Tom?
Yes.
Next, a request to put Jay Zigler on regular employment status.
Okay. Sort of the same thing, we would request to move Jay Zigler from probationary power plant operator 3 to regular employment status as a power plant operator 3. So he's back to regular employment status if you guys approve this. Jay has the proven skill sets and schooling to hold the classification. His ability to start and operate all our generation units from the power plant to the auglays is top notch. Jay's really developed into a strong problem solving. I mean, he has really came a long way. When Karen had asked about the schooling for AJ, and I mentioned there's 2 types of schooling that we're providing at the power plant. So we're doing the schooling of generation type schooling, and we're also doing substation, sort of the hybrid schooling. Jay is in the generation side schooling. When Jay started taking those classes, Matt helped pick a lot of the classes out that made this module up, and they are very math intense, very theory intense. And Jay is hit it out of the park. You know what? I've just been totally impressed with his skill sets. I mean, to sound corny, he has really taken off, doing a phenomenal job. So I'm excited about where he's at. I'm excited about what he's going to offer to us in the future. So I would respectfully recommend that we put him on regular employment status as a power plant operator 3.
And then again, this is just bringing them off of probation.
Yes, there is no pay increase on any of these. They're just coming off probation to a regular status.
We move Jay Zigler from power plant operator, or from probationary power plant operator 3 to power plant operator 3.
Second?
Karen?
Yes.
Dick?
Yes.
Jim?
Yes.
Bill?
Yes.
Tom?
Yes.
Next is a presentation by Spectrum Engineering Corporation on the Bryan Electric System Study.
Okay, this is the good stuff now. In 2014, the Board of Public Affairs passed a resolution authorizing Spectrum Engineering to develop a Bryan electric system study. And in that study, it was looking at all the capital needs of replacement, as well as modeling the electric flow and load flow in the system, as well as almost a short circuit analysis of the system. So this project has been very, very, very labor intensive. It's taken well over a year. Probably we're falling into the year and a couple month range. I know Al and Adam and the 2 gentlemen from Spectrum have worked closely over the last 2 years. In fact, they really got into the weeds and dug out information and did some good things. So I'm going to ask Al to introduce the staff members from Spectrum and kick this off.
We have Rod Surrey here and Brian Reese from Spectrum Engineering.
Welcome.
We provided each one of you with a package in front of you. We'll kind of go through that here. Anybody in the audience needs one? That one over there on the desk. The cover sheet are just each one of the slides that we're going to have up on the screen in case you want to take notes and everything like that. The middle power system study, this is the executive summary, and typically when we come present to a board or city council, we usually just go through the executive summary just from the standpoint of the knowledge of all the other documents, pages, prints, everything like that. Typically that's up to Brian and Alan and the rest of the group to understand and play with that on a daily basis. So we usually go through the executive summary. This is kind of what the presentation is going to be about. I'm not going to read this word for word. I'll let you guys do that. And then the last component is the system planning part. That's what Brian and Al is going to use over the next several years to present the capital portion of what we looked at in the study. And we'll go through, there's other portions of the study that they're going to use on a daily basis through operations. This is the part that they'll use for capital intensive type projects. So these are the components that we'll look through and probably guide you to as we walk through here. So again, why do a system study? And I think it's great. It actually ties in great with what Bryan presented earlier with the compensation and everything. Typically, when we come in and talk to a municipal utility about this, once we get into the weeds and start talking about the capital portion, they always start talking about, well, do we have the right staff to do this and everything like that. So actually, what you've done ties hand in hand and actually will present you with a good model to move forward over the next several years, having both of those tied together at the same time. So that's a good thing. But we want to look at, we've got on there identify weaknesses, but also look at strengths. Where is your system okay that you don't really need to worry about it? But we want to look at the capacity, the age, reliability, everything that you normally get with a call when a storm rolls through or something happens. The items you don't want to address from the public point of view, we want to make sure that we address intensively with the study. We want to look at the inventory, everything you have, what's the age of it, how it operates. We look at that from an evaluation standpoint, and what we do with the evaluation is, drive up and down the roads, take a look at everything, take a look at the poles, the quality, the type of construction, what the system's condition is in. It's more than just letting the software tell us what's going on. We also have to go out there and physically look at it and say, okay, how's it actually look? How's it rate? And then we model it in the electronic software. And we also use the equipment that you have. You guys provide us with the GIS model. We verified and validated what was in the model versus what was out in the field. We take all of that information. We'll go through the steps here in a second and create a master plan. Typically like to put 5 to 10 years. And how that works, we've got it laid out in there. Typically the first 2 years are followed, right down the line. But it's usually that third year where you start, an industry may have come in or an industry may have moved out or a new addition has moved into a different location. So that's typically where you start kind of morphing away from what your original plan was a couple years ago, but it still gives you a good roadmap as far as where it stands and everything like that. Additionally, that modeling, which you do have, Bryan, we left you a thumb drive, and that has all of the information in it, all the electronic files. It also has the electronic model and everything in case you purchase that software in the future or need somebody else to take a look at it for some other type of capital project and everything you have. So you have everything that was presented on that thumb drive, and then Al also has it uploaded to the site and everything like that. So everybody should have that, and if anybody wants additional files, I'll let them get with you.
That works.
So the process, we came in and interviewed, and this was one where, Bryan wanted us to kind of look at the system first and get our own. He didn't want to cloud it up with, what their, perception is and what they wanted. But the initial interview process was just what's going on. What are you dealing with? What are you doing there? Not necessarily what you want to do, but more of what you're dealing with, where you're having to go, what your heartaches and everything are. Then we go out and collect all that data, load data, evaluation of the system, age of the equipment, nameplates, everything to enter into the system. That field review goes on. We come out, review it, go back, build a model, come back out, review it, verify, run that system model, come up with a preliminary study, and this is what's kind of evolved over the last several months is preliminary study, come in here, sit down with the guys and say, okay, here's what we initially came up with. Now let's start talking about the items that we came up with just looking at the system itself. Now let's mold in what you guys see in the system, what you guys hear, what you guys would like. Then we incorporate that feedback from that preliminary meeting into that final planning, and that final report, which we've delivered, and now kind of going over with you today. It's busy up there, you can't really see it, but this portion of the slide is actually your system model. It's got the substations, it's got all the feeders, it's got the buses and everything like that. And what we've tried to do in that model is, one, lay it out kind of how your city is, but also those key points and everything, we'll see in a future slide here, is what they're going to use on their daily operations if they need to interact with a customer, look up data and everything like that. We tried to model that by, what substation it comes out of, what feeder it comes out on, and kind of a location, whether it's an industry name or a corner of a road or something like that. Some way that you can go in here and pick the points and everything to get that data out of the model. So that's how we did that. Now, the components in the total model, and this is also detailed in the executive summary, the system data. That's what we got from you guys. The GIS, the source impedance from your primary sources on the 138 and 69 lines, the loads from your customers, the peak load information off the system, the age of the equipment, the last time maintenance was done, maintenance records. We took all of that into consideration as we're looking at that. That's all put in the system data portion. The model, like I said, we create the model and then we start interrogating it. And the sections that we did, short circuit, I'll let Bryan kind of describe what short circuit is here once we get to another slide, but that's the fault current. It basically allows you guys to size your equipment appropriately. Protection devices, whether it's fuses, the relay, everything like that. And then also the customer fault duty. Each one of your large industrial customers has to conduct certain things to meet their OSHA requirements. And this information is what you need to provide to them. If they come and ask you, this is what you need. So it's all available for you. Arc flash, we didn't conduct and do the arc flash as part of this, but because we did the short circuit and everything, the arc flash can be done in the future. And it's actually one of the capital projects with the cost of what it would take to do that. It's more or less just a simple output now to run, evaluate, optimize, and then present you with the final results. Because the short circuit was done, arc flash just kind of flushes out after that. Load flow, again, we take a look at peak operating conditions, normal operating conditions, and then several conditions that may take place, whether you lose a substation, lose a power plant, lose a feed from I&M or AEP, what happens to the system, how does it need to recover, where are your weak points, and everything like that. And that starts, giving us the idea of where do system improvements need to be. It also gives you guys the idea of everything going on. If we have this condition going on, if we lose a substation, we lose a feed, the temperature's high, the loads are high, how can we then reconfigure our system to get rid of some of the maybe low voltage concerns for some of our customers and everything like that. All of that information gives you that. Device coordination, this just makes sure that everything is coordinated from the furthest point out all the way back to the most critical pieces on your system, whether that's the transformer or generators. And we just want to make sure that, like I say, it's coordinated. If something happens far out, we want to make sure that it doesn't come all the way back to the initial device and clear everybody off the line. We want to keep the outage as far out as possible while still keeping all the critical infrastructure protected. And then ultimately what everybody flips to is the system planning, usually the last page with all the dollars and cents on it. That's the final component, which we'll get to in a few slides. The short circuit, again, this is what you guys will use if an industrial customer needs to do an arc flash or size equipment going into their facility. they'll call up, want to know what your source impedance is on your system and everything like that for them. We provided that to you in electronic format. They're in PDF, so you can just click the search function. And for this one, we just tied in Allied, in case it was Allied Molded wants to add something. Just typed in the word Allied, it comes down, and we'll highlight where it's at. You can see what it is, and all the information that you need to provide them so that they can do work at their facility and everything, you can immediately give to them. You don't have to come back and consult with us. You have all that information right at your fingertips to provide to that. Now, I'm not going to discourage you from contacting us if you need to, but you have all that information for that. And it then ties to the system model. This is just a blow up of what was in the previous. It will show you the name over here, DG3, which would be, correct me if I'm wrong, that's Daggett sub, the third feeder coming out of that. And it goes to Allied Molded Products, their primary one. And you can come over here and see where that sits on your model and everything like that. Easy to search, easy to use, and provided your customer with what they need. Well, we also went in there, like I said, we looked at the system itself. We didn't just rely on the electronics, the software and everything to tell us what was going on. We drove the system out, looked at the lines, looked at the poles, looked at the condition of the infrastructure, and provided you with circuit maps on everything. This just kind of gives what these guys would need for just normal system operations. You have normal things that go on that may not be capital intensive projects that just go on. This kind of does it, and we give you a rating system of excellent, good, moderate, poor, very poor, and then what it takes. Tree trimming may be required for a moderate. And it gives you the map, your circuit map and everything, along with the ratings for the different zones and everything on those. So coming out of here at Baker, we can see over here in between Portland and Beach, there is an area where it's acceptable, but showing signs of deterioration. So keep an area on that. Tree trimming may be required. It's something to take a look at in your system under your just normal operations. Then we look at the system plan. It's difficult to see up here on the screens and everything like that. You can follow through on the system planning documents, but in the material provided to Bryan now, everybody, there's one lines, there's prints, there's larger documents and everything. This is a shrunk down version of the transmission one line. On that one line, we've ballooned areas that coincide with the system planning table. We've also put in diamonds. Inside those diamonds are the numbers that correspond with the item and everything like that, so you can see where on the one line of the system that the projects and everything correspond with. Just for some examples, project number 5. Where you can find these in the system planning documentation. On page 2 and 3, it kind of lists through the 20 projects. Starting on page 4, we start going into some of the details, high-level details on what those projects are, what it's entailed. This gives Al the ability to come to Bryan and kind of give a justification on what that project is and everything like that. So let's take a look at page 6, top of page 6, Daggett substation upgrades. And there kind of, it gives the history, the age, date of manufacture, date of installation of some of the equipment and everything in that location. And then what type of work and everything would need to be done, why it would need to be done, And then also, some other considerations. If you tie it back to your system planning table, again, the item number is listed on the left. Come down to item number 5. You see there are actually components that are underneath that. 5A would replace the 3 oil circuit breakers. That's this component right in here. Those have reached the end of their life, and not to mention they're also, an issue that you have to take care of environmentally and everything because of the oils and everything contained in them. Plus, the last couple winters, as cold as it is and everything like that, I don't think you guys had the unfortunate opportunity for this, but other utilities, those didn't actually function as well under those extreme cold conditions. So luckily, those weren't called upon for you, but I know the city of Auburn had one at the 9M substation where it did not function, caused that bus to go out, which dumped the entire city.
So, layman's terms for everybody on the board here that doesn't know what an OCB actually does, it's nothing more than it's not simple, but it's a breaker.
Yeah.
Like you would have in your house. It's either gonna be on or off.
Yep. Yeah, you'll get the incoming service, whether it's off of your lines or your wholesale provider's lines. It's just the switch, or more or less a switch in between your transformer and that circuit that's providing the service. Integral part, something you need to take care of. So we've got that to be replaced. And what we've put in here is also all of the timing and costs associated with doing that. Design for an engineering firm, or if you have the staff that can take care of that internally, the cost of the equipment and components, the construction, and what we looked at from construction is if you would go out and bid this work. It's not necessarily the cost for your guys to do it, it's the cost of if you would have to go out and bid work. You can choose at the time you want to do these projects if you have the capability of doing it in-house, and then that's just dollars and cents that you can move to other types of projects. But everything in here is if you go out for bid. And then the final commissioning to put it in place, and then the total. For Daggett, we're looking at replacing each of the breakers, installing what we call here 15 kV switchgear. That's actually the distribution side of it. After it goes through the transformation and before it goes out onto the lines, that switchgear, new breakers, relays, every component that gets it out into the distribution system. And then also, if you want to take a look at it, replace the transformer. If you go back to the detailed write-up on page 6, the power transformer was manufactured in 1975. So it's reached and beyond its useful life. So that was an easy one to look at from a standpoint of what it takes to replace. However, in the meantime, as you're doing that, we also, line item number 6 is just the substation maintenance. We wanted to incur the costs and everything in there and show you what the costs are and the importance of maintaining these. Because we're not going to be able to get to all the replacement of all the equipment that's reached its useful, lifetime. Maintenance is your best friend after that. Taking a look at it, making sure it's okay, making sure it's not reaching a point to where it's a failure point.
Can you
It
help
includes
us-
maintenance.
Can you help us understand, so the maintenance only goes so far, and then if the equipment's old, you're gonna have a potential failure in time?
Yeah, the maintenance, especially, different things that can happen on maintenance, for example, on a transformer. We'll take a look at the oil samples and everything, and you'll be able to tell based on the results of those oil samples what may be degrading inside. If something's going on inside, it'll show up in that oil sample. We'll also do electronic testing to see if there's anything happening in the bushings and everything, or the windings. to make sure there's nothing happening there. So those results will let you know if it's meeting its optimal condition or if it's starting to see some type of degradation. Based on that level of degradation, we can kind of, yes, bring it back in service, but you probably don't want to load it more than 75%. Those types of things.
Tracy, I'm gonna point out real quick so nobody panics at first. We do this testing today. That's why you did get 30 plus years out of this, and we're gonna continue this testing because it does give you indicators that something may be going wrong, so we can address it in a more of a proactive instead of reactive. But again, you're dealing with power systems, and sometimes even though you have an indicator, there is no timeline when that indicator is going to fail.
Right.
Okay, so that's where
Correct.
this group's coming from, saying, gentlemen, you have this indicator. It could happen today, or it could be a year from
Well,
now.
it could be extreme weather, as you talked about, whether it's cold or heat.
Yeah. Like I said, when you get into, that power transformer operates one way, your switches or your breakers and everything operate differently. Not only is there the electronic functions of those, but there's the mechanical functions. And those are really put under stress, especially under the conditions we had during the winters with the very cold, icy conditions and everything like that. Not only are they wanting to get the electronic signals to say, hey, something's going on, I need to react, but then actually functionally being able to do it. And that's where you see a lot of the problems, especially with the older pieces of equipment and everything like that. A linkage may break. If that linkage breaks, it doesn't work.
Not a breaker, then, right?
So those are items to look at. And those are items that are also, like you said, under the preventive maintenance. When you do preventive maintenance on that, you cycle it. You see how fast it takes to open and close those contacts. If that doesn't function within a certain period of time, that shows you something's failing with that mechanism. So it's great that you continue doing that. Wanted to make sure it was in the capital improvement to keep doing that on all locations.
Do you actually offer suggestions on the frequency of some of those preventive maintenance checks?
We can provide that. I don't believe we provided that in here, but we can send that over. When I get back to the office tomorrow, we can send that over, because there are checks that they do on a weekly basis.
Mm-hmm.
There are checks that they do on a monthly and quarterly, semi-annually, annually. Typically, the large maintenance and everything is usually on a 3 to 5 year rotational period, depending on how your system's loaded and everything like that.
It seems like, as far as the oil testing and stuff goes, it's not so much an issue as it is like the age of the equipment and the potential failure of like the contacts and stuff.
Honestly, the oil, I mean, as far as the lowest cost, biggest indicator that you can have is, we recommend on an annual basis to have the oil samples.
Right.
And then keep it logged,
Right.
because that shows you what's happening over time.
We do that now, don't we?
Yeah, typically most utilities that take care of their system have that done. And that's, like I said, that's one of the most important things you can do, along with going out and checking the settings, checking the readings, making sure that your tap changers are moving, are being reset, and everything like that. Making sure that the temperatures, the volumes, all of those settings are being looked at, recorded, and taken care of.
I understand some of the equipment we have would be difficult to get replacement parts for if it did fail, so it would be good to be proactive on it.
Yeah, and I mean, these are the big items. Some of the smaller ones, especially the switch gears you see in there, replacing the relays,
Right.
replacing the breakers in the switch gear, those are the ones where you can start running into issues of not having replacement parts. Having to go out to eBay and try and find somebody that is
Craigslist, right?
It's true. It's true. We've been down that road. So
So it goes, and this is the inside of it. I mean, you're dealing with, electromechanical relays that are basically from the original kind of designs. I mean, it's a functional system. It's a functional relay. But given that your customers are working off of microprocessor-based controllers, Usually their operations are controlled by PLCs and everything like that. You know, we recommend upgrading your system to that same level of technology, because it's gotta happen quickly. You know, if, take for example, I mean, Allied Molded Products and everything, those presses and everything, if they see a blink, you know, it causes scrap issues for them and everything like that. And that's where that coordination and everything comes into place. Line that up, it just helps them, you know, it gives you a more powerful system, more robust system to meet their needs. Also in there is upgrades at the power plant. You know, you mentioned, you know, several of the employees going from probationary to full-time status is at the power plant. And then getting what's in the power plant out into your system. One of those projects is to, you know, and utilize what you have out there. You know, utilize the small, compact substation that you have right there. So let's take a look at it and get it out further into your system. Use the space that's there. Build a new ring bus so that if, you know, gives you the flexibility to change some of these breakers and switches to route things throughout the system depending on what's needed. And again, you know, each of those projects is detailed out so you can do them all at once. You can do them in phases. It's just all a matter of what these guys need as far as functionality, what they have in the budget, and you know what you guys have as far as an appetite of being able to take care of things. And then moving on to some of the futures. Again, you know, all of your substations are well maintained and you take care of them and everything, but they're reaching their limit as far as age. But again, we wanted to give you the options of the different components to do it. Instead of just coming in and saying you need to replace that substation, you need to build a new one. Instead of saying, okay, yeah, you need to spend $2.5 million on a new substation, it's what can you do at each one of these locations to systematically improve and upgrade those. That's where in the study you'll have the number and then you'll have A, B, C, D, E, depending on what needs to take place at each one of those stations. Again, you can choose to totally replace it, but we can recommend ways to, you know, offset that cost and everything. Additionally, you have one of your 138 feeds from AEP. That's a long extended road run of poles and 138 line. This is a picture of it. It does run through a corridor. They are wooden poles. Those are again going to show age and everything over time. We do have the cost in there as the last project on the list to upgrade that line to steel poles. Again, required as you see fit in doing this, if there are certain areas. Items you can look at when that occurs is, you know, say somebody comes through and needs an REMC or IOU needs to build an underbuild distribution line through there and they know there's going to be work going on, that may be a good time for you to look at that section and everything like that. So the pricing that we actually put in here is to do a linear mile. And that would be approximately 16 poles and everything that would take to do those sections. And the pricing that we would have in there is based on pricing that was purchased on steel poles within this area within the last year. And then also the contractor's costs and everything for putting those poles in, foundations, and conductoring and everything on those steel poles for projects within this area of Ohio within the last year and a half. So those are options that you have. With that being a 138 line, there are some other additional items that you would have to take care of. You can't just choose upon yourself to go out and do that, like a distribution line or something within your territory. That will need to be coordinated with the wholesale providers because of different needs and different things, especially within the last few years of everything that they've got going on and everything they're doing on the transmission system. We want to make sure there's no congestion issues on if you take a section of that down and everything like that. And you'll coordinate that through Michelle and everybody at AM.
When you say steel poles on the corridor, are we talking like towers or the steel poles like the switch pole out on the corner of C, South Main? I mean, is that?
We're not a lattice tower or anything like that, just a simple steel pole. It doesn't necessarily have to be one with a foundation. Imagine if it was a corner pole or something, it's probably some type of concrete foundation that's bolted to that. You'll want those wherever it turns or makes a jog. For anything right through here, you can get those actually put in the ground just like you would a normal wood pole.
Okay.
So it's just
What's the life expectancy on something like that?
steel pole. It's going to go up just like most of the infrastructure you put out there of 25, 30 years. As far as useful life, as long as you keep things trimmed, keep it maintained. The advantage you have going down through here in most cases is you're not going to have semis making sharp turns and taking
chunks out of
things
the
out.
side.
So you have the ability there. It's just a matter of making sure that's a strong wholesale feed for you to take care of over time.
Question. I'm looking at the table that you've shown, and there's green and there's white, so I'm just wondering,
Priorities? Just separates the projects.
Okay. There's not a priority assigned to.
No, the priority, and this is with discussions going back, is the second column, the rank.
Okay, so that's
1, 2, 3, 4, 5, 6.
That's where I should look for the priorities in the right
Yeah.
side column. Okay, thanks.
And how we came up with that on most studies and everything, the protective device coordination is the first thing done, because that takes into consideration, what do we need to do to the system right now to make sure that whatever happens furthest out in the system doesn't affect the person closest or the equipment closest to the substation. So that's always normally priority 1, because that's also a safety item and everything like that. Priority 2 is, the arc flash. 1, it's just a simple output. Simple output, look at it. It's safety related. It gives you the levels of PPE you need and everything like that for the equipment and everything for the guys. Then it's a matter of starting to talk with these guys, looking at not only what the short circuit analysis, the load flow and everything, the engineering data that came out of the model, but talking with these guys, what are the customers saying? Where's your priorities? That's when it's looking at, reclosers for both hospital feeds and everything like that. Just gives you the ability to transfer load and everything like that to critical infrastructure components. And then it's a matter of, we get down to the 5th ranked item, Daggett substation upgrades. That one's selected, 1, because of the age of the equipment, 2, the customers and everything. And then also, if you, in the details and everything, which Bryan has, if you look in the load flow and everything, if you lose other locations, where's your weakest point in the system? That substation. And everything like that. So that's how the ranking and everything comes in.
So, Spectrum presented this information to Al and Matt and Adam in a rougher draft version several months back, and I did sit down with our team and we looked at Spectrum's rankings as well as what we have in the budget this year and where we need to go with this. So we already have a game plan based on this, and I agree with Tracy and those guys. Years 1, 2 are pretty easy, but once you start getting to years 3 and 4 and 5, changes with the economics of your utility. You know, businesses coming in, businesses going out, may skew this a little bit. Realize years ago we had a plan very similar to this that talked about removing the 4 kV and making this a full 12 kV system, and it was a 10-year plan. It took 18 and a half years to get through. So I would hope this doesn't take us an 18 and a half year period, because some of us will be retired by then, knock on wood, Al and team behind in front of me. But you have to have a plan in place to know where you're going. And you have to have something in place that tells you where you're vulnerable. We have that finally.
And again, you're dealing with an aging infrastructure, which, like the OCBs, I know we've replaced some of those with SF6 breakers, but we've always talked about that via the power plant with you guys. It's just something that there's, you know, we're gonna have to upgrade. I mean, look how old this is. It's like at the power plant.
It takes time. You can't do this overnight. And your fund balance that you carry in that electric department
Yep.
doesn't cover all this.
Right.
That's what I'm saying.
Well-
It's a constant reminder that you should be taking care of what you have for today, tomorrow, and for 30 years out. Bill, you have something you want to say?
Right, OCB.
Oil circuit breaker.
Is it up to us then to determine the priorities, like Bill says, an OCB at Daggett as opposed to?
Well, it can be a team effort. It's not solely up to you. It's not solely up to us. It's not solely up to
No,
Bryan
it's a
and
team
Al and the team. It's a team effort. What this gives you is the roadmap. It gives you the tools, and the other tools. You know, I'm not sure when the last time you did a cost of service study to make sure what you have in your rates as far as putting all this. This gives you the capital equipment and dollars and cents that you have to recover through your rates to do projects like this. It gives you that tool to give to that group and everything to make sure your rates and structures and everything allow you to do something like this.
So Tracy is actually being the bearer of all the bad news tonight. The cost of service study is actually built into the budget to start this year to look at our rates based on our future needs. And we need this to do the cost of service study.
Our customers want consistent, reliable, dependable power.
Yes, they like the lights on.
Every time they flip the switch or their power plant or whatever they're doing, they want it to work, and they don't want it to vary and kick off machines or, as good stewards, as stewards, we need to be good about what we do.
And here's the amazing, this is what, and I think we as an industry in a whole, and I think Bryan's probably heard this at the APPA conferences, is, we do a bad job marketing what we do for the cost. For typical residential customer and everything like that, for normal day's usage, is probably the cost of a large coffee from Starbucks, if you really break it down. And what does that actually power? What does it control in your life? It controls all your communication. It controls everything for that cost. Yeah, these components are expensive, but once they're in place, they're going to outlive most of us.
The staff you have in place today, I come from that side, so I know their thought process of the department and the culture of power generation as well as distribution has taken a very proactive approach and keeping the system updated, and if you want to call it refreshed. In other words, going through and always having capital projects that are always updating this system. This number could be a lot worse. It could be. There are a lot more weaker systems out there than ourselves. So we can pat ourselves on the back a little bit, but you can't let your head swell too much because there's still changes that need to happen. So
I got another question.
Okay.
So I'm thinking about the solar field and how we talked about the power plant here, but we really didn't talk about the solar field, and then how it is, that connects to our system. So was that evaluated also? And how?
Yes, it's in there. The way it's treated is it's just a generation source, it's a generation point. We do look at how that's then coordinated, because you do have a recloser, you do have it, if something happens to your system, it needs to come off. If something happens there, it needs to come off. How is that coordinated? Is it tied to then the next points into your system? We looked at that. So all of that was evaluated and everything, because it's a nice generation point and everything like that. It's a smaller number, but if you really look at the minute details of that, there's a lot going on that can really affect your system if that coordination isn't correct.
Right.
And Bill, the generation resource they looked at as a generation point.
Right.
We don't own the solar field. That's a leased piece of equipment. So you really can't analyze something you don't own.
I'm just looking at where it connects into our system.
Yeah, the recloser out of the line
Right, where it gets into how we
line.
file. Because we're not paying any transmission charges, as I remember.
No.
I mean, that's directly into ours.
It's a direct benefit to us because it
Direct
directly,
benefit.
it drops into our system. It offsets our profile on the grid.
So I understand that we would be looking at that because it's leased equipment on it. What about the aug blades and the hydroelectric? That's
Completely different.
completely different.
That would be a completely different study because that's not tied to us here. You'd have to take them in, and no offense to Spectrum, you'd want a hydro engineering firm to come in and look at the facility as a hydro plant, and then bring in double E's to look at the generation resources on that part of it. So it's a little different picture.
Okay.
They're not physically tied to us, so it's
No,
impossible to look at that.
He's right there because there's different components that you want to look at there. We would look at it from a system point of view as just that, a generation point. It's connected to the system, how. But to really get an understanding of that, it's a different animal as far as how it works, the components. It's just different from other generation sources.
The arc flash study, that's mandated?
Yes.
It is mandated?
Yes, utilities were exempt
Until 2009.
until a
Okay.
few years ago, but now it's required. But more importantly, you are always required to provide that information to your customers, because your manufacturing customers were never exempt. They always had to do it. Not all of them do, but they're required. So if they contact you, you have to give them the system equivalents at their point.
Does that have to be regularly updated, or is that something you just would look at as your system changes or your load changes or increases?
It would be a significant change to your system to really impact one of those. So if you would change, if you would add a substation or if you would add a significant load, we would want to model that in and give you that information. But all the information that's on the sheets and everything that they can source right now, it's going to be accurate for.
So in the past, we did have an arc flash analysis done on this system. There was a couple of issues we ran into with that analysis. One, the data was not handed over in this manner. So whenever we would have a industry call in and ask for particular numbers that affect their system monitoring, and those are the things that Tracy talked about, that we had to provide industry certain numbers. Because we didn't have access to those numbers, we were sort of held captive by the group that we had to do this. And it would cost us anywhere between $1,000 to $2,000 every time we got a phone call, because those numbers would not be released until this was all reran, and here you go. When we went out to do this, we knew we were doing the short circuit study. We did not jump in with the arc flash, but we had the idea behind us going, if the arc flash is there for the future, I want numbers that are ours, that we own, that you're going to teach us how to get those numbers. So that is what Tracy presented to us on the jump drive to Al and I, is all that data that's part of that. So we have it.
We use the numbers on a weekly basis. For industry, when they ask about available fault current, we use that, the model and all that data to provide that to our customer.
Also, if these guys need to size a transformer, size a piece of equipment for a customer, those same numbers are useful.
Anytime
here the last year, anytime we have a new three-phase customer, before Blair puts his green tag from the state, we have to give them available fault current transformer.
So you
This all helps with that.
just set one at best one tire, three-phase, I think.
Right.
So you've already done that?
We'll have to give them that information.
You have to give them that information.
Yep.
The follow-up question I would have, and probably the public would like to know, is if we have a new industrial area that we're trying to develop. Do we have enough capacity, say, if someone...
That was modeled in this system.
Modeled in this system, so we would have enough capacity then to have power there.
Yeah, and they modeled several different scenarios with different loads that may drop into that facility. So that's all in the report.
There'd be, have to, and I didn't see anything about a new substation, would there have to be one, or we could use the existing? Or don't you want
I'll
to
let,
bring that?
On the,
I'll let Tracy answer that.
on the, in the system study
Sorry.
executive summary, if you start looking on pages 4, 5, 6, and 7, those start going through all the different types of scenarios that we made your system act like, and everything to get output from. You know, we looked at it as, you know, everything on, and then we start, you know, taking things off. Also, if they look in the detail, we start bumping up load. You know, normal load, high load during the peak, and then we start going 10, 20, 30% all the way throughout the system under these same scenarios.
That's pretty impressive.
To see what's in there. So there's on that drive and what Al has on the site, there's if we would print this out, there'd usually be about 3 binders, 3 or 4 inches thick of just data. So I'm glad you didn't cut down a whole bunch of trees to do that. But that's all there. I'll actually let Bryan talk as far as, you know, needing a new substation versus upgrading, you know, existing ones, capacity and everything from that standpoint.
Kind of what Rod mentioned here is we took your system and then we added future load. We picked, I talked with Al here, northwest, southwest, and east. So we put loads in those particular areas on your system, and I ran the load flow, and it came up with the maximum amount that you could add without having to change any conductor size or add any equipment to support that new load. And if you wanted to go above that number, we put in recommendations to either increase the wire size, conductor size, or add voltage regulators to help the voltage at that point in the system for the new customer. So that's all laid out as well. So we picked those 3 key areas that kind of matched with the overall map for your future growth there.
So the partnership with Spectrum, the reason why it took a year and a half, everything that we were doing here, information was being fed there as they kept remodeling and growing this. So, yeah, Rod and Bryan and the team over there did a phenomenal job.
Again, because we've been doing business with you for many, many years. Good to have such a nice plan to use to go forward.
Thanks for allowing us to do that. And again, if you have any other questions, funnel it back through the guys. We'll be glad to push them to you. They'll be glad to share all the detailed information that they have.
Al?
Great.
Thank you, guys.
Thank you very much.
Next on the agenda is effect semi-monthly disbursements. Can I have a motion to pay those, please?
So moved.
Second. Dick?
Yes.
Karen? Yes. Jim?
Yes.
Bill?
Yes.
Tom?
Yes.
Comments from BPA and staff?
I think Sylvia included the all-glaze generation from 2012, the current graphical trends and usages. It's pretty interesting to see how the roof flows and whatnot. Realized last year we did have a unit down most of the year that we're working on right now. And in October to December, the water flow was terrible. So that's why the numbers are low, but it is interesting to look at and see the flow patterns and the output, so. Other than that, I have nothing else.
Brandon? All right. Anybody? Tom?
Thank you, gentlemen, for coming in and thoroughly confusing me, but I'll get a handle on it.
Glad we could do that.
Bill?
Yeah, I really like this power system study because the planning document, you get to the bottom and it's almost $7 million. I know what our fund balance is, the electric department may say it's 10 million. So there's a reason we have to have the fund balance that we carry to protect those assets and the maintenance of those and protect the infrastructure and have to upgrade and do those things. Just because it's not broken doesn't mean we have to continually work at keeping it up. So, good job.
Dick?
Yeah, thanks again. That was great. Really enjoyed that. I, for once, was following that right through, so thank you.
A good presentation, and now you've got your work cut out for you, you and Adam. And Matt too, of course.
Yeah. What I got? No, I'd like, yeah, same thing with me. I was impressed. You know, in an industry like this, you don't work under, you know, if it ain't broke, don't fix it. You gotta take care of it before it breaks, so, yeah, I'm impressed. You did a good job. Okay, with that, go into executive session. I just lost my sheet. Oh, here we go. Executive session to discuss employment and compensation of a public employee. So can I have a motion for a brief recess, please?
So,
Second, please.
Dick?
yes.
Bill?
Yes.
Jim?
Yes.
Karen?
Yes.
Tom?
Yes.
Thank you, gentlemen.